Hey, welcome back, guys. We're doing some dynamics. This time we're looking at impulse and momentum, and here we have a calculus example. So recall that this is the impulse equation, and when we're given f that is a function of t, then we need to solve the integral. So here we are given that we have a 2 kilogram particle. Our f is defined in 3 terms, all of which are functions of t, and we have an initial velocity of 150I plus 100J minus 250K at t equals 0. We're asked to find the time when motion is parallel to the YZ plane and the velocity at that time. So what does it mean when the motion is parallel to the YZ plane? Well, the derivative of position, or excuse me, the derivative of position is motion, and when the motion is parallel, then that means that there is no component moving towards that, right? So let's see, YZ, we could say this is a YZ plane, and if we're flying along, then that means that our X component, which in this case would be the up and the down, that would be 0. So let's start with this equation. Let's see where this gets us. Make some room here and say mv1 plus our impulse fdt from 1 to 2 is equal to mv2, right? Okay, well, we know our our mass is 2, okay, and our velocity, our v1, is this, so 150 I plus 100 J minus 250 K plus, and then we have an integral, and our integral is f, so 8 minus 6t I plus 4 minus t squared j plus 4 plus t k, and we're integrating all of this from 1 to 2. Okay, well, these aren't bad, right? We can do this. Oh, and not entirely as an afterthought, equals mv2, right? And we're going to be after mv2. So let's integrate this. We'll do this part and then we'll put it together. So just bringing this down a line, then what do we have? We have 8t minus 6 over 2, that's 3 t squared I plus 4t. It's t squared, so this will be 1/3 t cubed j plus 4t plus 1/2 t squared in the k direction. Okay, and we are evaluating this at 0 and at t, right? So let's see, 0 and t. And that necessarily means that we can put these together, right? So since we have the I, J, and K components of the velocities, then we just add these together. And what do we end up with? We divide the 2 from everything. It gets rid of it in the M and V terms, and it'll cut these in half, right? So let's see, V2 is then, let's see, half of this, and then 150 plus 4t minus 3/2 t squared I plus 100 plus 2 plus 1/6 t cubed. That's in the j direction. Then plus, let's see, that's minus 250. Okay, plus 2t plus 1/4 t squared in the k direction. Okay, and we don't actually need to group those together, do we? All right, so this is our equation for the velocity, right, which we're going to need in a minute, but we don't know what the t is, which is where this first one comes into play. So the time when the motion is parallel is the time when the I component is 0, right? So we would say for part A, we would say V2 say I equals 0. So 150 plus 4t minus 3/2 t squared equals 0. We factor that out, and when we factor that out, I could punch a bunch of buttons, but I already did. And what do we get here? Where is it? There we are. So this, when you factor, say, use quadratic function, or if you have a fancy calculator, you can use that. This gives us that t is equal to 11.4218 seconds. Right, so at 11.4218 seconds, then this is 0. Okay, and so then we want to calculate V2 for the whole thing. I guess this is part B, right? So here we need V at t equals, and I guess make a little parallel symbol. T equals t parallel. Okay, so what is that? That is 100, and this will say V2 equals 100 plus 2 times 11.4218 plus 1/6 218 to the third. This is in the j direction, and that's going to be plus negative 250 plus 2 times 11.4218 plus 1/4 11.4218 squared. Okay, and that is in the k direction. Right, when you run these through your calculator, you get v squared, or excuse me, v2 equals minus 125.5 j minus 194.547, and that's in the k direction. And probably a good idea to put some units on this, right? And that's going to be in meters per second. There you go. So it looks a little intimidating at first, but it's not too bad. Thanks for watching, and I'll see you in the next video.